recording. So good evening, guys.
Good evening.
Yes, so we are here. So I'm Javed. We have Dodo here, and we also have Samuel. So today we are here to have a discussion on our second seminar topic.
Mhm,
That is part of our machine learning course that we have taken from BTH University.
mhm,
So this paper, which I have it in my hand for reference, talks about status scope and problems of requirement engineering for machine learning. Okay, and what they have done is that it's basically an international survey,
mhm,
and what I see is it's a collaboration of 8 universities. They
mhm,
have come up, they have done some previous background paper studies and they have found out like how important is requirement engineering for machine learning based systems, and there was not enough emphasis paid for this particular topic.
mhm,
So they had some background study, and they've extended this study by coming up with a survey questionnaire, and then passing on that survey to multiple professionals across the world. Okay. It is mentioned that in total there were 188 complete responses
mhm,
from 25 different countries, and there's a lot of different points that is been focused on this. So one thing, so we'll start with some points, like for example, requirement engineering related activities. It was found out there was no dedicated engineers. Okay, so in the abstract, it is mentioned that it was mostly conducted by project leaders and data scientists. Of course, we'll discuss about that, why and how, and do you agree with this or not?
mhm,
It was also seen that requirements were collected mostly in the notebooks. There was no separate tool or anything like that.
mhm,
And then uh, there were some points on like non-functional requirements. What was the main focus of it? It was brought into notice that data quality, model reliability, and model explainability were the main focus of non-functional requirement.
mhm,
Then there was also discussion regarding main challenges
mhm,
uh, what we encounter in machine learning systems. Okay.
mhm.
So with this, we'll begin. We'll first discuss on when can we call a software system as machine learning system. Samuel, do we have you? Okay, okay. Maybe you are speaking or you are not on the camera. So
What was it, John?
no, no, you are not seen on the camera. So I thought I'll just. I was not sure whether the camera was aligned to you. Okay.
Okay.
Yes. So we are just discussing right now like how software, what are software systems and what are machine learning based systems.
Yeah.
Okay. So in the introduction, they say that if within a software system, even a small part, okay, if you are trying to automate with machine learning model, then we can still call it as machine learning or ML based system. Okay, so this discussion is applicable even for such kind of software systems where even a small part of software system is using machine learning model. Okay. So typically, requirements, the collection, the people who collect the requirements in the software engineering is basically a requirement engineer. So we have dedicated system engineer, we have dedicated requirement engineer who have multiple interaction with the customers.
Mhm.
And then what we have seen is they'll discuss with them, they'll document the requirements, and those requirements are again there are some iterations. So we sit through the technical team, the testing team, and the people who have the experience in that domain. So we discuss around, and then we say, okay, these requirements are ambiguous, these requirements are not possible, these requirements are conflicting, and then with those discussion we refine them, and after refining the final document or final thing what we arrive at, we call it as requirement specification. And
Mhm.
this requirement specification we maintain in some tools, right now in my current company, we use Code Beamer. It is a tool that we use for requirement maintaining.
Mhm.
So I would like to have some insights from you guys, for example, Dodo and Samuel, how it has been done in your company.
All right. Thank you, Javid, for this nice introduction. So yeah, talking about the paper. So it's a really good survey that they did in here, where we were trying to explore the challenges practices associated with the requirement engineering in machine learning enabled system, based on the survey conducted among practitioners from various countries. So it tackled mostly the roles involved in requirement engineering in ML systems. And we all
Mhm,
know that this is one of the biggest challenge when it comes to machine learning, like compared to software engineering, where you have some requirement engineers, you have some site reliability engineers that will always get the final user feedback and updating the software or the models of the or components of the software is much easier. But when it
mhm,
comes to machine learning, from my own experience and from my company, I'm more into the data science side.
okay,
So I don't
okay,
have like a very big or very deep knowledge of software engineering. So I have a little in that. But like talking about machine learning, I should say that the most difficult part of when we are doing a machine learning project is about the business understanding or the requirements understanding, because it's a
mhm,
crucial part. If you miss it a little bit, or if there is a little misunderstanding, then we will spend a lot of time in developing a tool or a software
mhm,
machine learning tool that will not respond to the final user's requirements
agreed.
or questions.
Yes,
This is really what we don't want to do, right? So
yes,
that's why most of the time, people might think, okay, machine learning is really fancy. We are using some deep learning models, some traditional machine learning models. But it's really fancy. It's cool when you're running a model, you're training it, you get the epochs. It's really nice. It's working. You get the accuracy, training score. Everything is fantastic. But how
mhm,
about the requirements? Okay, what question are you answering? Are you resolving
yes,
anything? I know a lot of data scientists or machine learning guys that would say, oh, yeah, I'm training a model or something like that. But even when you ask them about the model itself, what is the final task? What the model is doing? What it will help to do? Then there is a problem in that. And
mhm,
I would say, in a machine learning project or a pipeline, 80% of the time we are trying to understand the business and we are trying to get the data and prepare the data suitable,
mhm,
get the data in order to put into the model, implement it, and then train it, and then we follow the life cycle of the machine.
okay,
Uh, Coming about the requirements, there is something that I would like to say. I like to give this example, right? Most of the time, I mean, even when they were only software engineer, and this happened also in software engineering before we talk about machine learning. Most of the time, what happened was you have somebody, let's say a professional of a certain domain, let's say the hydrologist or the doctor, you know, or the pharmacist and so on. They get the knowledge in their field, and there is
yes,
the programmer or the software developer or that guy, the tech guy, you know. And still, you know, even in software engineering, they had a problem to understand each other, because
yes,
it really happens, that the perception from the professional is not the same, of the professional of a domain is not the same as the programmer, because you might think, okay, binary, you might think 0 or 1, you might think in a you get a different perspective, where the professional where you are neglecting the values or that zero, or that 0.001, when you neglect it, it's really important in terms of the dimension, like when it comes
Yes.
to the professional. I remember we were doing a machine learning projects where we were trying to predict the water potability. I like to
Okay.
give this example because it's really, really, really a great case. We were predicting water potability where we had like a time series, a time series data. I wouldn't say time series, but a table data where we had like physical, chemical characteristics, and then of the variable we had to predict was actually a binary target, like potable or
Okay.
non-potable.
Okay.
So we had to do the data analysis and so on and build the model. Okay, so one student came and built a very fantastic model. It's predicting, it's giving accuracy. But when the teacher asked, okay, how did you do the data cleaning? Because there was some missing values in the data that he got. Okay, I replaced everything with zero.
Okay.
It's a way to replace missing values, but we are talking about physical chemical characteristics. Okay, let's talk about the pH, the how to call it, the pH hydrometric or something like that.
pH level. Yeah.
The pH, like which is ranging, if it is 7, it's neutral, so it's a water drinkable. But if it is
Yes.
like above, then 13 is like a basic. Then what is it called? If it is lower than 7, then it's acidic, right? It's
Yes. Yes.
undrinkable. So the student that replaced everything to 0, it means it is considering all that part of the data as acidic, and he ruined all the data, and he trained the model with it, and then everything was wrong. So that's why
Yes.
it's really good to understand the business before we are starting to use the model, so or to build anything.
Those are really good points, Toto. Yes, we would like to hear something from Samuel. What is your experience in terms of requirement collection? Kind of.
Yeah. Right now I'm working more in like a packet core engineer here, but which might not involve directly with the requirements, but among the experience that I have with requirement engineering over the years of experience, I can explain a little bit. So here, in comparison to the document, so yeah, so just I have my screen on my over my laptop on my screen, so I'm just looking up. So, anyways, so when you see that this document especially, like it gives us this comparison of ML practices in comparison to what a traditional software requirements is actually being done, right? So,
Yes.
yeah, well, while looking at these results of this survey that they conducted, to understand the practices that are currently being done and also the challenges that we have in this requirements engineering for like machine learning systems. The integration of ML components into software systems, I think, would actually resolve more number of challenges that we currently are facing. Like, for example, explainability. The paper was suggesting fairness and explainability, and they were also suggesting iterative experimentation.
Yes.
This is a interesting thing, and like non-deterministic behavior. Such kind of things. I think if we could actually integrate more ML components into the software systems across various sectors, I think we'll be able to achieve a better way of dealing with this requirements engineering in applied ML systems in practical way. So
Yes.
I think through the paper, I see that this survey, yeah, as you said, like there was, I think, 188 survey people,
Participants. Yes.
participants, yeah, participants, and maybe from 25 different countries, right?
Yes.
That gave us insights into this data, which is why very good when yeah, in terms of diverse collection of thoughts. So yeah, like that's what I see in terms of what both quantitative and also qualitative analysis were being performed on the response of the survey.
Yes.
So what the key things that I consider were like the a very different like significant difference between the traditional RE practices versus these ML projects that with these project leaders and data analysis versus the traditional roles we have, like, right, business analysts, analysts, and there was a other one. So while the techniques that they use, that is a different thing. Traditional requirements engineering, you obviously will try to find more information based on these through interviews and prototyping, right? And
Yes.
these kind of things are slightly less used in ML, right?
Yes.
Uh,
Yes. Yes.
so more interactive way of tools are actually used. So that is one thing. And so basically, machine learning specific non-functional requirements are being significantly used, like more than I think more than a couple of percentage, like 10% of the survey givers or the practitioners do not even consider this non-functional requirements in their projects as well. Like, for example,
Yes.
data
Yes. Yes.
quality,
Yes.
reliability, explainability, like we
Hmm.
just talked.
Hmm.
So managing the customer expectations along with having the required aligning the required data, um, uh, you know, by the people that are actually collecting, doing the requirements engineering, is actually a challenge.
Hmm.
That's the challenge that the paper is starting to talk about.
Yes. Yes.
And, excuse me. Yeah, the paper talks about how we can adapt new systems require for these requirement practices for this engineering, ML related systems, and
Yes.
it like to identify the underlying problems in a better way, in a established in a way, in order to ultimately, like we talk better address the customer, or at the receiving end, whoever it is at the receiving end. Yeah.
Yes. Yes. Yes.
Yeah.
Yeah. Good points, Samuel. And yeah, again, we expect this machine learning algorithms or machine learning models to work. So we train them on different set of data, and we expect it to work on a different set of data, or maybe in the real world. Okay. So that also makes it very important that the data what we collect. So this would be the second thing, most important thing, the data what we collect. The data itself is like a requirement here. Okay.
Absolutely.
Unlike you have a software developed, any software product where you have the requirements, and you design everything, and okay, if there is any change in the requirement, this requirement will affect this particular module because your entire software is modularized. Okay.
Yeah,
But in case of machine learning model, it's like completely black box. Okay. So even if a small thing change, even if a small assumption change,
yeah.
then whatever you have trained is of no use. You'll have to retrain it again. The same. That's why it's also difficult to maintain the machine learning modeling over a cycle.
Absolutely. And one question is coming again and again, even
Mm-hmm.
if we understand the business very well,
Yes.
even if
Mm.
we have like a data with quality, even if we train the model very successfully, there is
Mm-hmm.
always a question that comes is the uncertainty of the model.
Exactly.
Yeah, and that is
Yes.
really important. This is not
Mm-hmm.
what we can really, master or really, put in our hand and say, okay, we master the uncertainty. So
Mm-hmm.
it is inherent with any model, like, because
Yes.
models, after all, they are only based on assumptions, right? From the
Mm-hmm.
beginning. Okay, we could say compared to statistical or some regression models, statistical models, machine learning models today learn directly from the data. So they're not
Exactly.
really parameterized or such in a such way that they follow some equation or some formulas. But what I would say is they try to learn from the data. Yeah.
Yes.
And when they try to learn from the data, there is several aspects, in related to their to their learning or to their understanding, or even after the model is predicting. Okay, but what is the uncertainty? What is the reliability of this model, even though it had like a good training and test score?
Yes.
When it comes also to the data, it's a very big problem. When we have to collect the data, that is the first. The data collection. When after we understand the business, we move into the data collection, and this is a really big challenge because the data is not only like in a bank where you just go and pick the data and use it, right? So we need to collect the data, and we need to
Yes.
use instruments to collect the data most of the times, right? So when it
Yes.
comes to we want to measure some, we use today what we call those IoT devices, for instance, to measure the temperature or the air, or I don't know, the velocity here, the pressure. We need to use those instruments to measure all the parameters and get the data we want. But
Yes. Yes.
what is the efficiency of those measurement equipments? How accurate are they? So we are always, losing control by a little, like at every single step, like the measurements, the data quality. Sometimes you have missing values. Today you measured, but someday you forgot to measure it or to record it. Have some NAs there. Like it's a really big challenge.
Agreed.
The
Agreed.
requirements and the data collection, or the data quality. That is the most challenging part, even though we understood the requirements very well.
Yes, yes, yes. And most of the times, what happens, Dodo and Samil, is that, for example, I was going through some articles which was talking about this problem that the data is mostly available in the developed countries. We
Mm,
take the data, we train the models,
yeah.
but there is most need of these models is in developing countries or underdeveloped countries because they lack the resources.
Mm,
But whatever trained model we have with that developed countries data, that might not be applicable at all there. Okay, because
mm.
they might there it might be a completely different
Yeah.
perspective.
Yeah, absolutely. And this comes to like what I'm dealing with some of the times. Like when it comes to,
Hmm.
I was talking with some professionals, some data scientists working at Google. They were doing
Mm-hmm.
some predictions with water and the climate and so on. So they trained some good models, right? Using some
Yes.
basins different areas in the world, like in Europe mostly.
Okay.
Imagine you are training a basin in Europe.
Mm.
And
Mm.
in Europe, it's snowing, right? And in Africa, mostly somewhere in Senegal, it never snows, right?
It's mostly
Doesn't snow
desert.
at
Yes.
all. So you are
Mm.
taking account one more parameter, which is the snow. And how
Mm.
about in Senegal? So if your model is learning more the patterns of the data of the basins in Europe, and you want to apply it directly in a different area, in a different geographical area, it will be a really a big,
That will lead to a bias, definitely.
yeah, it will
Mm.
be biased. So we really need to be careful about this and try to maybe build more general models like that,
Mm-hmm.
able or capable to what we call the parameters transferability, over the time and the space, like, which is really important, so that from a location to the other, that the model is able to learn, and
Yes.
from a time to another. For instance, when the climate 30 years or 50 years ago is won't be the same, like after 30 years or 50 years. So also over the time, even though if it is the same location, we need to ensure that this is perennial, and this can reproduce very well the data. uh, uh,
Mm-hmm. Yes, yes, yes. I agree to the point. And yes, there are some background studies as well, which they have mentioned, like one study regarding Kashner, and there he talks about the relationship between the requirement engineering and the machine learning and how important it is. Okay. and they say that here requirement specification based on training data, okay,
Mm,
that itself is like a learned the learned specification, okay, that itself is like a requirement here
mm,
in case of models, okay. So in case of traditional software, how we take the data, we collect the requirement, we have some iterations, we sit with the technical experts, and then we finalize and come up with the software specification. But here the
mm,
data or the pre-processed data, whatever we have, or the learned description, that itself is like a requirement. And yeah, they also talk about some more studies where they talk about this non-functional requirements, how important they are, the
mm,
quality of data which you covered, like how it is, how important it is. Assumptions, definitely those made can really affect the model behavior, okay. Those things have to be taken care.
mm,
uh, and then here, I think in this research method, they also frame some research questions. The first research question is the contemporary practices of requirement engineering for machine learning enabled system. Okay, so questions like how are requirements elicited, how requirement elicitation is done, how requirements are documented, what kind of non-functional requirements are addressed, and which non-functional requirements play a major role, what activities in the requirement engineering is the most difficult or most relevant. So
mm,
this is one of the research question, and the sub questions that has been the focus of this paper. And second one is the requirement engineering related problems
mhm,
that are faced by the practitioners or the professionals who work in model learning based systems.
mhm,
Okay. Then of course they have discussed about survey design here,
mhm,
where they came up with a questionnaire, some with multiple objective questions and some with the descriptive questions.
mhm,
So the whole idea was to cover up the understanding of the practitioners.
mhm,
The model, they also have talked about the data collection method, how they have collected it. It was like mostly an online survey,
mhm,
and they mentioned that there are many participations. Actually, there were 276 participants, but among them, only 188 have completed. So this study considers only the 188 people responses.
mhm,
Okay. And there are some really good results. Okay, so we will talk about those results. So just to mention that since we are talking about the biases,
mhm,
so we cannot come up. I mean, we cannot consider the validation of this paper unless it covers different demographies. Okay, so
mhm,
here we see that it covers basically different countries, 25 different countries, and it also considers different professionals. Like there are data scientists who participated, there are project leaders, there are solution architects, okay,
mhm,
even the test manager. So all those different kind of people have participated.
mhm,
If we talk about the experience, and most of the people are again, it's a diverse experience,
mhm,
but most of the people were on the younger side. So I was thinking like it might be one of the threat to this paper, but
yeah,
it's we can also it's also uh, understandable that machine learning itself is a evolving field, and
yeah,
only in recent years there has been
yeah,
so much of study been
yeah,
made. Okay,
okay,
so it's okay that most of the participants are 1 to 2 years or 3 to 4 years of experience. Okay.
mhm, mhm,
So let us talk about more about the machine learning cycle steps.
mhm,
And what do you think is the most difficult challenge? Okay, there has been some finding here. Of course, we'll quote them as well, and we'll also talk about. Do you agree, or do you think? Do you want to add more to that?
mhm,
Yes. So what they have mentioned here is in terms of relevance,
mhm,
the problem understanding again is the most was the most relevant according to the in this survey results. So most of the people found out that problem understanding was a major thing. It's very important for machine learning systems. Data collection is also very important. That is second most important. And data pre-processing, how we pre-process the data, that is again third most important. So again, after that you have model evaluation, model creation, deployment, and the model monitoring. Okay. Similar way, they also try to understand like what step was perceived as most difficult. Again, majority of the people felt that problem understanding was the most difficult thing. We need to correctly understand the problem, and unless we don't understand it, if we design something, then that can lead to a misalignment.
Yeah.
Okay. Again, data collection, pre-processing, model deployment, these were next important stuff. Finally leading to model creation and model monitoring. So one thing what surprised me was model creation. Being a software engineer, I always feel like algorithm or creating an algorithm is the most difficult part, or that's most important. But this result, what we see here, it stands something in the last third or
Did you think was
last
more
second.
important? What did you think was more important?
The algorithm or
Algorithm.
the
Yeah.
main because that's the more that's the
Yeah.
crux, right? That's the
Yeah,
core
yeah,
thing. So
yeah.
being a software engineer, we always feel okay, what is complex is most important. Okay, but
Exactly.
that's not the thing here. The
Yeah.
simplest thing
Mhm.
is the understanding of the
Yeah.
problem what we are trying to address. So
Yeah.
do you guys agree with this study?
Uh, yeah, in some extent, I would say mostly yes. The life cycle you have mentioned just now, I mean, from the paper was the CRISP-DM methodology, and you have also some other type of methodologies like the KDD, the knowledge, the discovery, and so on, data mining, which is using a data mining process. So we have many of those life cycles, but what I prefer as well and what I use is the CRISP-DM life cycle that starts with the business understanding. And I mean, the studies, what the study mentioned, I think, is really what I feel, because when it comes, I mentioned it, like 80% of the task is not the ML or the most difficult part, right? It's not, okay, algorithm, LSTM, so, or the transformers model, I need to code, etc. Maybe, I mean, in a software engineering perspective, you might be, oh, I like it, you write a lot of code in there, and then, it's really fancy. But okay, would you write a code or do a model that no one will be using? Like, it will be just waste of time and resources, right? So it all
Yes.
starts with the business understanding. We need to call all the stakeholders and discuss with them. What do we need to do? When do we need to do it? How do we need to do it? What are the elements? What are the threats? What can be the problems, and so on. So we try to cover everything. Then we start with, what do we need? What data do we need? So if we need to collect the data is not present in the nature easily. So we need to collect it, and then we need to process it, because the data we are collecting is not clean. It's not something that we can use directly into our model. Otherwise, it would be biased. It's no sense. Mostly, we can get some data that is maybe not processed at all.
Yes.
So to align with data engineers sometimes that we collect, I mean, millions of rows of data, right? When it comes to big data or such. So they are providing the data in a Parquet format, or some format that we as data scientists need to reutilize in order to rearrange data, make it in a usable format, either if it is like, and depending also on the business understanding, sorry, I have to come back to that. Depending on the business understanding, we choose what data we need to collect.
Yes.
Okay, for every single task, the data corresponding, right? And it's the business understanding that tells you what data to collect, and it's the business understanding and the data that tells you what model to select. So you don't come with, okay, I want to build a model with LSTM, and you start building. No, but you need to understand what you want. You need to understand what data you have, and you clean the data, you analyze the data, and you are like, now, okay, with all this information I got, I think I'm going for a regression task. I think I'm going for a classification task. I think I'm going for computer vision, NLP, natural language processing, and so on. So if we talk with the stakeholders and they say, okay, we need a model to predict something. We
Mhm.
want to predict who is the winner of the next elections. We want to predict if it will rain tomorrow or not. So in this
Mhm.
kind of situation, we are able to say, okay, we can think of some time series data, right? If we come
Yes.
to, okay, we want to predict the forest cover over the time. So we can think of some satellite images already. Yeah.
Mhm.
So we need satellite data in there. We want to do some NAIR, or predict the next word, or do some chatbot that will talk or interact with the between the patient and the doctor, something like this. So you can think of, oh, okay, maybe natural language processing is there. So it's really the business understanding that tells us this is the data to use. Yeah.
Mhm.
When we get the data, we process the data, we clean it, we make it really good and usable. Okay, now we need to select the model. Yeah, and it's the data that tells us what model to use, because every type of data and the model that is suitable for it. And when we
Mhm.
also do the data analysis, that is also a very important. I wouldn't say that business understanding and data collection or processing is important. I wouldn't say it's important. I would say it's crucial. It's really,
Mhm.
really something we don't miss when we do like machine learning. And once we do the processing, for instance, you have maybe like thousands of columns, yeah? But maybe from that thousands of columns, you don't need all those columns. You need to
Yes.
identify, okay, if we have like a time series when we are predicting one column, so we know, okay, then it's a supervised learning because you have a target column to predict and your data
Yes.
is labeled, yeah?
Yes.
Then you know, okay, if your data, your target is labeled, then you know that you have a supervised learning. But when you don't have like a target, so you can think of an unsupervised learning already. And then from
Mhm.
supervised learning, we are doing what type of target do we have? Okay, it's continuous data. Then we are like, okay, we go for a regression task. So it's a time series. So we could
Yes,
think
yes. So
of
the data itself can give a
data.
clue about what models we can choose.
Exactly what model
Mm.
to choose. And when we do also the data analysis itself, and we study the correlation and the causality, there
Mm.
also it will give us more information on what model would be more suitable from the model that we thought of already.
Okay.
So it will
Okay.
narrow it down more. Once we're done with that stage, okay, when we say, okay, we have poor data, like
Mhm.
so we do all the inputting, we replace the missing values. We have like low data, then
Mhm.
we're not going to think of the most robust model, because
Okay.
sometimes the simplest model, machine learning model, can resolve our problem, and it can work much better than a robust model that in training will work well, but in test will be super poor.
Will flop.
Yeah, because
Okay.
it won't remember. So it depends on the volume of the data. It depends on a lot of aspects. Then we choose from those models which one we are going to use. So we can run several models at the same time, train them, and see the output from each, and choose which of them has the best results in training and testing, which one is not underfitting or overfitting. And then from there we can go for some feature engineering or
Yes. Yes.
hyperparameter tuning.
Yes.
Yeah.
Sure. So yeah, coming to this questions and then the results, we'll try to connect them. Like one question, what has been asked was like which roles work with requirement engineering in the machine learning systems, and the survey found out that uh, the majority of them are where the who were dealing this requirement engineering were project lead, and then followed by the data scientist and then business analyst,
Mhm.
developers, solution architect. And if you see the requirement engineer, they are like almost after 5 or 6, they rank 6th here, okay, or 7th in the survey, okay.
Yeah.
So that means there are no dedicated requirement engineers meant to collect the requirement for ML based system, and this is actually one of the big problem, because for software engineering we have the professionals, we have the qualified people who know what kind of questions to ask to the
Yeah.
customer, who know
Yeah.
what technicalities are involved, who
Mm.
know like which of these requirements are ambiguous,
Yeah.
which of these so those kind of in-depth analysis is really required, and that can be one of the problematic thing what they have mentioned.
Mm.
And requirement elicitation techniques is mostly again the traditional ways, like they have interviews, they have prototyping,
Mm.
which are still okay, because interview I still feel like face to face asking is the best form of communication what you can have, because it will not lead to any kind of assumptions.
Mhm. Mhm. Mhm.
Then so those were the things that they mentioned.
Yeah.
Then coming to uh, this one, the third question which we talked, because second question we mostly covered the machine learning cycle steps, and which are the most difficult steps and which are the most relevant ones. Coming to the third question, it talks about the significant differences in the
Yeah.
practice when we practice the machine learning model versus software engineering.
Mm.
Okay. So let's talk about that thing, and then you can share your experience how it is.
Yeah.
Samuel, do you want to highlight some of the points if you think?
Yeah, sure. So yeah, it was very good th experience to learn from you people. And yeah, when it comes to these three questions, especially like like the typical roles that which are the typical ones that are working with requirements engineering for machine learning systems. So in this way, I think what I can from my some experience I have in different industries like gaming and software and also the packet telecommunication. What I see is like business analyst, like as the paper mentions, as well as you guys have experienced as well in software development, traditional software development. Based on findings of this survey and this paper as well, we see that in general, we see a lot of requirement engineers and business analysts play more, prominent role in terms of collecting the what is the requirements engineer requirements, but
Hmm.
based on the findings of the survey, it also shows that project leaders and team data scientists are the primary individuals that are involved in requirement engineering for machine
Yes.
learning systems as well.
Yes.
That is good. This is contrasting with the traditional software development requirement engineering as well.
Mm.
So,
Hmm.
right, that's one thing. And one, like in this, the typical roles for requirement engineering for machine learning systems, one possible explanation for this kind of shift is also could be the nature of machine learning models itself.
Hmm.
Like which often which requires like expertise, deep domain expertise, data driven insights, and that is decided by the model selection or model picking itself.
Hmm.
Like because project leaders, as the paper mentions, and data scientists may have additional or technical skills into a domain that required domain knowledge that is needed to select or document or manage the requirements and effectively uh, document and collect elicit these requirements into the machine learning model context. That is what I see. That's the transition that you see because in selection of roles involved in machine learning requirements models. When comes to second question, that which machine learning life cycle steps are determined the most
Or the
relevant
most
and the least
difficult or
difficult to
relevance,
perform, right?
yes.
Right. In this way, from the paper, let me start from the paper. The survey is actually suggesting more on requirements engineering activities are crucial across stages, across various
Hmm.
stages of machine learning life cycle. But
Yes.
even then, however, certain steps are considered to be more crucial and more
Hmm.
difficult to perform. These steps, these relevant steps, like for example, data collection, feature engineering, model training, and model evaluation as well. Collection, engineering, feature engineering, model training, and model evaluation, because these stages directly impact on the quality and performance of the machine learning solution. You see, so I think these are why the paper illustrates that, themselves as crucial steps. So these steps, these difficult steps, why they if you go in another depth into this, like why these steps only are crucial, like these are managing the customer expectations, and so that we are aligned more to the requirements with the available data, right? So I think that is the challenge that is emphasizing on importance of communication and domain expertise and technical skills, in navigating or in selection of machine learning models, basically. So yeah, that is some insight that I can find from the relevant difficult machine learning life cycle steps. Yeah. And when it comes to the third one, yeah, I like what differences are in requirements engineering, right? What was the question? What was the differences in requirements engineering
Yes,
practice
traditional
between?
practices and yeah, in
Yeah,
requirement engineering, machine learning versus software engineering.
yeah. Earlier we discussed this roles and then their steps, and now the difference in traditional versus machine learning requirements engineering practices itself.
Yes.
So I think we have we always have this experience of traditional life experience, and now we are looking into the paper into how the systems have changed. Like what I crucially find here is like in comparison both of them, I find more like data centric nature. Okay, and I can also see complexity of the models. And I can also see there is an uncertainty of algorithm. Okay, so if it comes to data centric nature, and see, because like these 3 points are the major differences that I observe in traditional practices versus machine learning practices. So basically, in this data centric nature, what I see is like data centric. Basically, the machine learning systems are completely rely on a lot of data, and we all know that, and which is moving towards or contributing towards a very unique challenge in data acquisition, and data acquisition. This is the major requirement engineering practice difference, and pre-processing the data, and cleaning the data, obviously, which is quality assurance. That is the major practice difference. And traditional systems usually more focus on functional requirements, without the same emphasis on data, like all of these data related considerations, so data centric nature is the major one of the first major difference between a traditional practice and a machine learning practice. And the second comes to model complexity. Machine learning models are highly complex, and we know that a production model, I mean, and also very non-linear, right? And very non-linear. So requiring expertise in this algorithm selection. You want to select an algorithm, you need to, like we previously discussed in earlier, we need a lot of expertise in our domain knowledge in this algorithm selection, and basically tuning the parameters, and model evaluation. These things are also quite, model complexity is also one difference between a traditional and as well. And while traditional systems involve more simpler algorithms, right? A software architecture or something, software engineering, they are more simpler algorithms and architectures. And last point, what I wanted to say is there is uncertainty of algorithm as well. There is an algorithmic uncertainty as well, because since machine learning algorithms operate in a more chance, like a probabilistic, the framework is completely different. They introduce the uncertainty, and like they they introduce the predictability or unpredictability into the development process.
In the model behavior, yes.
Yeah, in the
Yes.
model behavior, right? Exactly. This uncertainty is the challenge for requirements, like we said, validation or management. If you want to manage the data and the validation, I think this is the major problem, elicitation. If you want to do that, this is the primary challenge that I see uh, traditional practice versus the as well to a traditional these which are not which not are very commonly used in traditional, very prevalent in the traditional
Yes, yes,
thing.
yes.
So I
Yes.
think these are something I think yeah like data centric nature of the system and model complexities and uncertainty of the algorithms also. Yeah, something that I think, is
Yeah, good
contributing.
points and good thoughts from you, Samuel. I think I am also looking at the time, and it looks like we are kind of making it lengthy.
Yes.
So I'm not just going through the threats and threats to this regarding this paper, but yeah, just to mention, they have addressed some of the threats, and they have tried to validate them, like right from the survey being reviewed by a lot of qualified PhD students to yeah, the procedure, what the tools, what they use, the research tools, what they have used, they try to address them. So let's give some concluding remarks. So we all understand that requirement engineering is important. Yeah, apart from these threats, what I also felt was that since this survey was given as open online survey, I assume that the participants who participated in this were mostly the people who were dealing with the machine learning algorithms. Okay, so that can also be a thing, like how Samuel mentioned, that the people who are qualified, they understand more, so they participate more in requirement engineering as well. Okay, so that can be one of the bias for this. Maybe if we do an organized study, and if we go to each company who are involved in this machine ML model, and then if we check with who is actually collecting the requirement engineering and what kind of practices they do, that can lead to a different revelation. Of course, that's completely a thought what I have. So concluding, of course, this is an empirical study, and it has given some good insights, both on the qualitative side and the quantitative side. It has addressed some of the issues that are faced while framing this requirement or requirement collection. Okay, it also talks about uh, some of the non-functional requirements, and also the differences in the traditional way that we already discussed. Okay, that's how they conclude, and they also tell that this is open for more uh, study. We can take this as a base, and then we can continue the study as well. So, do you have any concluding points before we close?
Yeah, just to sum up, that's really good that we had this discussion. It's really brainstorming, and we get insight
Yes.
from everyone, and it's really we're generating ideas. Like I'm burning with ideas, so it's really really good that we are having this session. Just in the last question, where they say, why are there differences in practice in terms of requirement engineering from machine learning to compared to traditional software engineering? I think, honestly, and as a professional, and from my experience, that data scientists compared to software engineers, they're not designed to work in just programming languages. When you are a data scientist, it's basically you can work in every single industry. You are just flexible, right? Okay,
Yes.
the more experience you have in a particular industry, of course, the more you are reacting, the more you understand the business, you understand it, the problem, and you can resolve, right?
Yes.
If you are a data scientist, you can work in a financial industry, you can work in a pharmaceutical industry, you can work as a hydrologist, you can work as like work in a logistics company, as I do right now. So I didn't know about logistics. I didn't study logistics really. But
Yes.
okay, in the beginning, it wasn't that easy for me. to get everything. What is the shipment? What is the container? What's the utilization and so on. So I needed to, across the jargon. Of course, I needed how to code. I knew how to code. I need how to build the machine learning models and train it and build it, present the data. But I needed someone to help me, to understand the business, to understand the data itself, because there was a table data, and you have to understand what means what different fields mean. So I would say, those requirement engineers are just kind of bridge, between the business requirements and then the data scientists or any machine learning engineers.
Yes, yes.
But honestly, I'm thinking like we are moving towards, like, a data scientist is just basically a software engineer that is using machine learning algorithms, but that also tries at least to be the requirement engineer, but like, or to understand the business. So he's the bridge. He can. And like, I'm not trying to oppose with the paper, but honestly, I think that data scientists is a part of the work of a data scientist is also the requirement engineer. So he is really able to go get the information that he needs, and he can already think of, okay, what data is needed, what model, and so on. So it's really good to involve the final developers and the final users in the discussion when it comes to business understanding. All stakeholders to take part of the discussion and have this discussion interestingly. And also, maybe in software engineering exists requirement engineers, but I really don't believe that is worse than in machine learning or in data science, because still, even though they are requirement engineers, they are software reliability engineers in software engineering, they still have problem in business.
Yes.
They still are facing issues of the customer said, I didn't want this, we were looking for something, and it's always a challenge. But the feedback is important. So whenever it reaches, it's to update, and it's an unending process.
Yes. And of course, moving into future, it would be a collaboration of more and more different kind of professionals, software engineer, and then data scientist, and then the people who are actually facing the problem, medical industry, or all this collaboration. One industry cannot solve the problems. And of course, in the short duration, we cannot discuss everything as well. There are so many other things that we might have missed out. But I think it was altogether a good discussion. Apart from this recording, also we'll continue our discussion in future, and we'll have more such insights. So thank you, thanks Samuel, Dodo, for having some time and discussing this. With this, we can close it then.
Yeah, looking forward to meet you next week.
Sure. Yes. Thank you.
Thank you. Bye.
Bye.